Hello everyone, my name is Jennifer Ng and I'm a solutions architect with Amazon Web Services. With the spread of COVID-19, businesses and organizations realized there was a need to change and innovate quickly. Equinox Media, a business that was formed with the aim of developing transformative technologies, media, and experiences that inspire and equip consumers to pursue fitness every day, recognized this need to innovate quickly and rolled out the Varus platform. Varus is a first-of-its-kind fitness platform powering two products, the Varus mobile application and the SoulCycle at-home bike. And this was accomplished within 6 months using AWS serverless technologies. For those who are new to serverless, it allows you to run and build applications and services without worrying about the underlying servers. Serverless removes the infrastructure management tasks of things such as server or cluster provisioning, patching, operating system maintenance, and capacity provisioning. This enables you to shift your operational responsibilities to AWS so you can focus on your agility and increase your innovation. Equinox Media was able to do this with the Varus platform using a data lake strategy and highly scalable serverless solutions. Some examples of the services that were used include Amazon Kinesis for real-time data streaming, AWS Lambda for running code when needed without provisioning servers, AWS Glue, a fully managed extract, transform, and load service that makes it easy to prepare and load data for analytics, Amazon DynamoDB, a fully managed key value and document database that delivers single-digit millisecond performance at any scale, and Amazon Athena, an interactive query service that makes it easy to analyze data in Amazon S3 using standard SQL. To go into more details on the architecture and the business use case, joining us is Elliot Cordo, the Vice President of Technology Insights at Equinox Media. Elliot oversees all things related to data and technology innovation at Equinox Media. He has more than a decade of experience implementing cutting-edge data-driven applications. He has built and he now oversees Equinox Media's complete data infrastructure leveraging AWS. Elliot is also an AWS data hero, and I am super excited for him to share with us the serverless analytics solution used by Equinox Media.
Hi everyone, I'm Elliot from Equinox Media, and I'm here to talk to you about how we leverage serverless analytic architecture to handle rapid scaling and innovation. So in this talk, I'm going to share an overall architecture, as well as a few technical deep dives on specific problems that we solved, which you might run into in a similar architecture. So a little bit about Equinox Media. So Equinox Media debuted Varus, which has two primary products that we deliver to consumers, which is our mobile app, as well as a studio at-home bike. And this platform is built upon the world's most powerful fitness collective, which includes Equinox, SoulCycle, Pure Yoga, Precision Run, Headstrong, MyoDetox, many more, and many more to come as well. So Varus is a data-driven company. Data is really the critical asset, which is going to be able to help us deliver this omni-channel experience where digital meets physical. So when we talk about being data-driven, we're talking about BI and analytics for sure. That's a very important component. But just as importantly, we're talking about how we're using data and how we're using this technology to add new product features and new experiences for our users. So some of these experiences, for example, are activities. So using this wealth of data where we have both physical and digital activities, and metrics all in one place, we're able to deliver a seamless kind of timeline and experience, including visualizations and insights on top of those activities. Using this data, we are also able to provide a contextual, personalized recommendation system and experience to our users, which is really catered to their goals, the activities that they like, and is really personalized for them. And this is extended into AI programming. And so we are able to build programs and routines which are, again, tailored to an individual user at a one-to-one level. And all in all, we're just trying to build products that help break plateaus for our members and help them achieve their goals and live healthier lives. And we're using this data and machine learning to really help our members live a healthier life. So we are working on building custom metrics and health scoring, and again just on an individual level, giving people the insights they need based on the way that they are working out, their goals, and again, like a really one-to-one personalized experience. So only a month after Varus's March 2020 launch, and with its communities in more need than ever for an in-home fitness option, Equinox Media worked really hard to try to make Varus content and make the Varus platform more widely available. We therefore accelerated our rollout by more than 6 months, rolling out to all Equinox US members and also launching our bike, our in-home bike, in early preview and then full rollout. And most recently, direct-to-consumer products. So if you are a non-Equinox member and you don't have a bike, you can actually subscribe to Varus and receive the fitness content and our experiences. An important thing to note is even with this acceleration, we continue to accelerate our innovation. During this time, we launched numerous new product features and experiences for our users to really help them achieve their goals. So the reason we were able to do this was very important thing was actually the technology and the foundation that we laid. So since Equinox Media and Varus was a ground-up build, we had the opportunity to really evaluate the technologies which made like the most sense to us and allowed us to really deliver in the most efficient fashion. So both the app and kind of data architecture at Varus are completely serverless in nature. So we did this for a couple reasons. One, scalability and kind of predictable performance. And then secondly, and just as importantly, as you're ramping up a product and you have kind of a usage pattern which is somewhat unknown, is being able to really quickly be able to predict cost and having paying per transaction, so to speak, will really allow you to really model that really accurately. Additionally, we followed like the well-architected framework, which really helped us focus on operations, security, reliability, performance, and cost, which really helped us again maximize on those serverless principles that we set forth to use when building this platform. So I'll take you on a quick overview of our platform. So the first area which I'll talk about is activity ingestion. So this component of the platform is where we are able to take events, both first party and from our partners and external systems. These are workout activities, these are metrics in both real time and batch, and serve these in a fast store, in this case DynamoDB, as well as emit those records to our data lake. We have a data lake first strategy, which I'll talk more about, where we store both raw and processed data. This is where our activity data comes together with additional first-party data and fires all of our machine learning pipelines, services the data science community, as well as our business intelligence. As mentioned, just as important as servicing insights, we are actually building features that power our apps. So our Activities API is a serverless API layer using API Gateway and Lambda, which serves our activity functions within the app in the bike from our DynamoDB fast store. Additionally, our user experience, specifically our navigation, is completely driven by machine learning. So we have a robust recommendation and personalization architecture where we serve recommendations and personalized experiences through our app. So the first area we'll do a deep dive on is our activity ingestion. So the goal of this platform is to make ingestion frictionless and event-driven. And as mentioned, we need to consolidate a lot of disparate sources of activity. So we developed a universal data model, and we used an approach called the grammar modeling approach, which is essentially person acted on object. And if you use that kind of a framework, most events or any event that you can think of can fall within this kind of modeling concept. So a sample of our data model is shown here, where essentially at the event root, we have a number of standardized attributes which are common across all of our activities and all of our metrics. We also have an object context where we store either raw or processed attributes which are specific to that event or activity. We also often store the raw payload of the object, of the original records themselves. So for our activity ingest platform, we have two ingest methods, the first being our speed layer. So our speed layer is basically our event-based real-time ETL engine, as well as fast storage. So both internal and external apps will call this API, emitting events in real time. We first have a API gateway and Lambda-based API, which receives these events and then publishes them to a Kinesis firehose. This Kinesis firehose then starts an asynchronous process that stretches from here through our fast store to the data lake. So from this Kinesis firehose, Lambdas will go through and clean, standardize, and inspect all the incoming messages. Once that is complete, they are written to our Dynamo fast store. Again, this serving layer which supports our Activities API and other services. We then use Dynamo streams and Kinesis firehose to route these events to downstream processes. We use Kinesis firehose specifically to essentially emit these events to our internal landing bucket. So with this architecture, we really accomplished two really important things in terms of delivery. So in under a second, we are able to make these real-time events available to our applications and our downstream consumers through our DynamoDB activities table, as well as our Activities API. Additionally, within a 10-minute window, these events are queryable and processable from our data lake. So allowing our analysts, our data scientists, and our machine learning pipelines to act upon this data in a very short window of time. So the second entry point to our activity ingestion pipeline is event-driven batch. So even in the most modern systems, you're going to have to deal with receiving flat files and JSON files and all sorts of file-based transmission. So our goal was to, really make this process as efficient as possible and reduce end-to-end latency. Instead of having a once daily cron or something, of that nature, we really wanted to, hold a similar SLA to emission to our data lake and our fast stream as the real-time speed layer. So we embraced our serverless principles. We tried to build this almost completely serverless, or at least using ephemeral resources. We decided that intelligently queuing work was really key to doing this efficiently. We were mindful of exactly once processing, not only to reduce duplication, but also to make sure that we are being super efficient with our resources. Obviously, processing something twice isn't efficient. And all this leading to our desire to make this process as fast and performant as possible. So to accomplish this, we developed a novel queuing system, which we named Cuberoo. So Cuberoo in and of itself is a relatively simple three-tier, kind of application. We have API gateway, which is backed by Lambda, and then writing and using Postgres RDS for persistence. And it's important to note that this Postgres RDS is our only non-ephemeral resource in our entire data platform. So the way that this works is flat files, JSON, different file formats are landed to external landing buckets. We then have a Lambda function, which is a file copier, which takes these and moves them to internal landing buckets and also registers the files with our Cuberoo service, essentially creating a marker or a record for every file that we receive. This also includes metadata about the file. We then have a launcher, which wakes up on a cron, a 10-minute cron, and checks what work needs to be accomplished. Based on the work, the type of data, and the metadata, it will then provision and start up a number of clusters bootstrapped with config and with the correct code. Once these clusters are complete, they will go and acknowledge and complete the work, or they will re-queue using the Cuberoo system for a similar secondary data flow. So all in all, this allows us to provide a similar SLA in delivering this batch data to our Dynamo real-time store, as well as a data lake in the order of something like 10 minutes. And there's no reason that we couldn't set the cron to be even more frequent with more data coming in, or with a tighter SLA in terms of delivering the data. We're also working on enhancing the system. Something to consider is intelligent scaling, because as we have run history and we have the metadata of what is incoming, we can actually really hyper-tune our clusters and be super efficient in terms of cluster sizing, in terms of cluster config and Spark config. So therefore being even more efficient, reducing over provisioning and increasing performance. So as mentioned, we have a data lake first strategy. So one of the primary goals is a pretty common one for a data lake, which is that we want to be able to store anything at low cost. All this data is valuable to us, even the raw data itself. We also want to reduce onboarding friction, and based on the variety of data that we're bringing on board our platform, this is a very high priority. So we do consider our data lake to be our single system of the truth, and we built it so that we could plug in multiple processing engines as needed. So in order to accomplish this, we first ended up choosing the Delta Lake file format for our underlying storage engine, and I'll talk about that more in a minute. We store all raw and processed data and use the glue crawler and metastore to really create like this central repository of all the data that is available in our data lake. And then we are able to essentially bootstrap our Spark clusters, as well as Amazon Athena are able to use this metastore to provide a consistent environment across our tools and our processing engines with the same metadata. So one lesson learned and something that we had to solve for was storage optimization. So a problem that you typically run into at a data lake is what they call a small file problem, which is where you basically have a large number of small files that are of a non-optimal size for storage and processing. This can result in, if you're using a query engine, really suboptimal performance if it needs to scan and retrieve like a large number of files. It can even run into difficulties and failures and timeouts in these processing engines as well if you're running into too many partitions or just scanning too large a number of files. So we actually have a case, since we chose to do everything as event driven and kind of real time as possible. Our event driven batch and our Kinesis fire hose produce many small files throughout the day. So really a perfect storm of a small file problem. Additionally, our data sets are not completely immutable. So we do sometimes receive restatements to existing data. Additionally, some of our event data comes in a little late. So we may get data that with an event date that was hours or even days ago. And these two issues require us not only to deal with small files, but actually compact updates into existing partitions within S3. So we tried to solve both of these problems in several different ways. So we used the traditional big cluster Spark approach for reading and rewriting partitions, as well as even some novel experiments in handling this in a serverless fashion. So in the end, we chose the Delta Lake open source file format. So Delta Lake is a Parquet compatible file format, and it contains extra metadata, which essentially helps you deal with upserts. So it allows for upserts, and it also allows for native compaction. So this problem that we were spending a lot of engineering effort and also some operations effort on to maintain, just to store the data, is now completely seamless. So as a result, we were able to scale with relatively no major performance or scalability issues. The promise of the model for serverless and the scalability profile was really true for us and held up well. Additionally, the data which we were able to collect both in our beta as well as our pilot, helped us really come up with a predictable cost profile, an actually low cost profile, and something that has remained relatively accurate as we've scaled through this rapid growth period. And most importantly, not being running around, putting out fires, dealing with operations issues, and even dealing with unexpected cost issues has allowed us to continue to focus on feature innovation and moving our product forward. So in summary, if I were to recap, try to make sure you guys walk away with a few takeaways. First being, if you are considering extending your data platform or building a new data platform, I would urge you to consider a serverless platform, both in the data lake, your query engine, as well as processing. AWS has really enhanced these services and really matured these services, and it's becoming easier and easier to build a serverless analytic platform. Even if you're dealing with old school, kind of batch processes, I'd urge you to think about how you could make them more event-based and more real-time versus defaulting to the standard, daily cron. Just if you look at the kind of integrations between Lambda and S3 and all the things that Lambda can trigger off of at this point, I think there's a lot of opportunities to make these kind of batch-based workflows, more efficient and more orchestrated and less scheduled. Perhaps you can take some inspiration from our novel Cuberoo system. So in terms of data lake storage optimization, if you are getting large files once per day and they're immutable, Parquet will probably serve you really well. Or if these kind of other aspects of updates, late arriving data, small files are relatively sane, then it's probably not something you need to worry about. But if you do have immutable data, if you are dealing with a small file problem, it probably makes sense to look at your storage layer and consider technology like Delta Lake or Hootie or Iceberg, which are all very similar technologies, which were built basically identifying this problem. And then finally, something that I didn't focus on much in my presentation is infrastructure as code, which if you are building a serverless data platform is an important thing to consider your IAC strategy as well as your AWS Lambda deployment strategy. Thinking about these things up front and kind of building them in as you are thinking about conventions, the structure of things, naming conventions, will really save you a lot of time versus having to retrofit and kind of do this and rework in a existing environment. Thank you very much.